All right, pre-lesson 2-3. This is a doozy. What rhymes with 2-3? Doozy. Now, I will say this. The doozy part of it happens over here. The actual lesson, I don't think is that bad. But there's one problem on your homework assignment, and it asks you, is there possible 0, 1, or 2 triangles with these dimensions? All of this is just for one problem. In my opinion, this is the lesson. The problem is, this, I think, is where all your questions are going to come from. For one problem. But it's interesting. So just chalk it up as interesting. We'll get there. We'll save that for last. Let's start over here. So, the whole lesson is the law of sines. And this is the law of sines. Now, what I need you guys to do is, don't look at it as this overwhelming thing. Look at it as 3 fractions. This fraction equals this fraction, which equals that fraction. Now, before I even begin, you see the little c, little b, little a, big B, big C? The big letters represent angles, always. The little letters represent sides, always. But also, little a is opposite big A. Little c is opposite big C. Little b is always opposite big B. Hope I said that right. Notice I put a 90-degree angle in here. Here's the thing. This law works for non-90-degree triangles. And somebody might say, well, I thought you said you needed 90 to use SOHCAHTOA. That's true. But the law of sines, the beauty of it is, this will work for any triangle, right triangle or non-right triangles. And in the real world, what do we probably have more of? Non-right triangles. Anyways, if you were in class, we'd talk about surveys of properties. And there's some really crazy dimensions of properties. And this is where this stuff starts to have some application. So anyways, this is basic middle school math. We have 2 fractions that are equal. How would I find x? Well, if fractions are equal, so are their cross products. For example, 2/3 equals 8/12. So I'd go, hey, 8 times 3 is 24, 2 times 12 is 24, and I'm going to piggyback this rule to solve this. These are 2 fractions, and they are equal. So I'm going to go ahead and multiply this way and say that must equal that. And then I divide by 7, and I get x is 8/7. You're going to be using this every time you use the law of sine. Now here's a big moment. Number 4, you only need 2 of the 3 fractions. In other words, I got 1, 2, 3 fractions. I only need 2 of them. The question is, well, which 2 do I need? And here's the part that answers that question. You got to pick the 2 that have 3 of the 4 parts. What do you mean by that? Look at this triangle. I tried to make it non-right triangle looking, and here's the deal. Here I obviously have angle A, so it looks like I'm going to use this one. And I also have side A, because that's opposite angle A. So I'm going to pick this one fraction, and I'm going to go sine of angle A, which is 23, over side A, which is 12, equals. And now I have to pick between this one or this one. Not both of them, just one. And I can just look at this and say, I got side B there. I don't know what angle B is. So I'm going to pick this part of the formula right here. And I'm going to go sine of angle B all over side B, which is 18. Now, I'm going to show you how to solve these in the actual packet lesson, but this is just how you get kick-started to the point where you can solve this. Now, this is obviously a little bit different than this, a little harder, but I'll show you how to do it in the packet lesson. Now, deep breath. Here it comes. So, number 6, where did I get number 6 from? Maybe from your homework, okay? So number 6, that's what this is all about, building you up so you have a chance at understanding number 6. Again, number 1, number 2, number 3, number 4, number 5 has to do with all of this. Meat and potatoes. This right here is just some dessert that you don't even like Oh, mincemeat pie. Yeah, like who even wants it? But here it is. It's part of your assignment, and it does show up on the quiz, so we need to understand it. Couple things. Rule number one, every triangle has 180 degrees. Rule number two, there are acute triangles. And that's kind of like this one, where all the angles are less than 90. But there's also obtuse triangles, maybe like this one, where you have a 97 degree angle here, makes it greater than 90. This would be considered an obtuse triangle. Now maybe you guys are used to like these, where it's clearly greater than 90. That's probably what's in your brain as far as an obtuse triangle, but this is also, because it's got more than 90 degrees in one angle. Now, here's a very easy law of sine situation. Now I'm going to go back to here. Remember this red one that I set up? You're going to be finding angle B, okay? And so now, let's say this is the math problem, 52 and 97. By the way, 97 and 52, that adds up to 149. And let's say you do all the math and you find out using the law of sine that x equals 62. And you haven't done anything wrong with your math. And by the way, this is going to happen. I would add 62 to this, and I'd get 211 degrees. Question, back to this. You can't have more than 180 degrees in a triangle because you have to have exactly 180 degrees in every triangle. So this flat out doesn't work, and you would say, hey, these dimensions have exactly 0 triangles with this sort of setup, with these dimensions. It's impossible. It doesn't exist. Those are the easy ones, okay? Now's where, if you're going to have questions and concerns, ask me a million questions, but here's my explanation for it, okay? Make sure I'm on there. Okay. So now, let's say I go through this math problem, and again, I'm not really doing a law of sine problem. I'm just saying, watch what happens. I go through the law of sines, and I discover that x is 64 degrees. And I say, okay, that's 64 degrees. Well, this plus 64 is 136 degrees. The question is there any left over? Well, of course there is. I would subtract it from 180, and I'd get 44 degrees, and I'd say, this is 44. And see, now I have, because these numbers simply work out, I have at least one triangle with these dimensions. Now here comes the twist, because number 6 says, do you have 0 triangles? By the way, 0 triangles only happens if something really weird happens. That's why it's easy to figure out. But if you do your math and you actually get one that works, that means one triangle exists with those dimensions at least. Now comes the tricky part. Back to the fact that there's acute triangles and obtuse triangles. Once you find an answer that works, what you do is you now say, okay, I'm going to take that answer, and you're going to ask yourself, is there an obtuse triangle that also exists? And what you're going to do is you're going to take your answer, the answer you found, you're going to find its supplement. And in this case, 180 minus 64 is 116. And you're going to take a look, and you're going to put 116 degrees in here. Of course, it wouldn't look this way. 116 degrees would look that way. And then if this thing goes off that way and this thing goes off that way, does it look like that's going to form a triangle? No. In fact, how do we mathematically prove that that doesn't exist? Well, if I add this to this, doesn't that already take up 180 of my degrees that I need? So when would you get 2 triangles? Well, you would get 2 triangles if you take this number, for example, let's say you found this to be something like, let's go, I'm just guessing, let's go like 97. All right. You go through this problem, and you find out that this is 97. Now what you're going to do is take that 97, subtract it from 180, And now I'm gonna get, what would that be, 90, 83 degrees. Okay? And now if I take that 83 degrees, the supplement, by the way, 97 would have been like that, but 83, then I add this to this, that would be 155, and I would definitely have some left over to form the second triangle. I know that's confusing, and it's going to take some time to iron out those wrinkles, but that's it for the pre-lesson.